Hi class, today we are going to speak about length. By the end of the topic, the learner should be able to state the units of the measuring length, convert units of length from one form to another, express numbers to require values of significant figures, find the perimeter of the plane figure and circumferences of the circles, find areas of plane figures, and application of length to real life situations. Then the body of content, unit of the length, that is millimeters, centimeters, meters, and kilometers. Conversation, conversation of units of length from one form to another. Significant figures, perimeter, circumference, and area. Then the example of length is used in measuring tape. Then introduction. Length is the distance between 2 points. SI unit of length is meters. Conversion of units of length, that is 1 kilometer is 1000 meters. 1 hectometer is 100 meters. 1 decameter is 10 meters. 10 decimeters is 1 meter. 100 centimeters is 1 meter. 1000 millimeters is equals to 1 meter.
Yes, so on continuation of the same, we are going to look the significant figures part of introduction. And here we have to consider some things. Uh, the accuracy in which we state or write a measurement may depend on its relative size, depending on the various methods we use. It will be unrealistic to state the distance between two dots, maybe A and B, as 158.278 kilometers or meters, as more reasonable figures is 158 kilometer or any measurement used. 1.8.27 has been expressed to 5 significant figures, but mostly we are encouraged to use 4 significant figures. The last point here is 1.8 has been expressed to 3 significant figures, but I've recently tell you that mostly in mathematics we have to express figures in 4 significant figures. So
we are going to talk about perimeter. We all know that perimeter is the total length of the boundaries of a plane figure. Perimeter is a length and it's therefore expressed as the same unit as length, that is in meters or centimeters, depending on the units that you're given. Now we are going to talk about the perimeter of a square. We all know that perimeter is the length of all boundaries. So the perimeter of a square, which has equal sides, is side 1, side 2, side plus side 3, up to side 4. For example, the perimeter of a square. A square is a 4 equal sided shape or a figure. Let's say our length is L. When looking at a perimeter, is the total length of the 4 sided of a square. That is L plus L plus L plus L. That's our perimeter. Let's say it is in centimeter. For example, let's say L is equals to 7 centimeters.
If L is equals to 7 centimeter over square, that means all sides is 7 centimeters. So our perimeter is 7 plus 7 plus 7 plus 7 centimeters, which is 28 centimeters.
So we are going to look at the perimeter of a rectangle. It's also obtained by adding the measurement of the sides of the perimeter all round. For you to get the perimeter, you do the distance all around the figure itself. So the formula for doing the perimeter of a rectangle is length plus width plus length plus width, or simply you do 2 into length plus width. For example, we have to find the perimeter of a rectangle. This is the figure of a rectangle with length here and width. So to find the perimeter, the formula for finding the perimeter is equal to 2 into length plus width. This is the length, this is the length will be 10 centimeters and width will be 5 centimeters. So perimeter is equals to 2 into length, which is 10, plus width, which is 5 centimeters. So perimeter now is equals to 2 into 15 centimeters. So perimeter is equals to 30 centimeters. Okay, perimeter of a triangle. We have various types of triangles, such as a right angle triangle, a scalene triangle, equilateral triangles, and isosceles triangle. So to find the perimeter of these triangles, we just add all the three sides. That is, for example, the sides might be A, B, and C. So we take A plus B plus C to get the perimeter of the triangle. For example, find the perimeter of the triangle below. So this is the triangle of 7 centimeters, 6 centimeters, and 4 centimeters. To get the perimeter of this triangle, a formula is equals to perimeter is equals to A plus B plus C. A, B, C are the sides of this triangle. Therefore, perimeter is equals to 7 plus 4 plus 6 centimeters is equal to 7 plus 4 is 11. 11 plus 6 is 17 centimeters. Therefore, our perimeter is equal to 17 centimeters.
Okay, perimeter of a circle. The perimeter of a circle is also known as the circumference of a circle and is obtained using the formula 2 pi r or pi d, where r is the radius of the circle and d is diameter of the circle. For example,
is the length of its circumference. So perimeter is also referred to as circumference. So yani perimeter is equal to circumference. In the same definition, ni venye sasa hii ni measure that circle ndio maana inaitwa circumference. Sawa? The circumference is equal to pi d. Si ndio? Where pi inakuwa a given variable constant. Inakuwa ni what's it? It is 22/7. Okay. While d inakwanga ni kama umepatiwa a radius, umepata mostly umepatiwa radius, d is equal to 2r. So that's the d. So ukiona hizi mbili, you can calculate the circumference of a circle, also known as perimeter of a circle. Going for an example, let's say our radius is 7 centimeters. So we can take it to be as 22/7 multiplied by 7 by 7 multiplied by 2. Okay, calculating this 22/7 times 14, what do we get? Yeah, and our perimeter is 44, which is centimeters. Okay.
okay, you are going to look on areas. Areas are total surface covered by a figure. In this level, we'll just learn areas of few objects. For instance, there's so many areas. There's area of a triangle. You can find the area of a circle, area of a rectangle, area of a square, and many others. So we are going to specify on the area of a triangle. On a triangle, it is the total area of a triangle is a total surface covered by the triangle. To find the area of a triangle, we use the following formula. That is a half base times height, or you can use 0.5 base times height. As you know, 0.5 is equal to half. So we'll just look at an example regarding the area of a triangle.
The area of a triangle is given by a half base times height. And our base is 4 centimeters. Our height is 3 centimeters. So if you substitute the values in the formula, we get half times 4 centimeters times 3 centimeters. So when you divide that 4 by 2, you get 2. When you multiply 2 times 3, that is 6 centimeters squared.
We are going to look at rectangle, area of a rectangle. A rectangle is a four-sided polygon with opposite sides which are equal and parallel to each other. To find the area, it's the total surface covered by the rectangle. Area is obtained by finding the length times the width. Hello?
So this is the area of a square. It's the total surface area covered by the square. Its area can be obtained by using the formula S times S. So given a square of side A, the area of the square is A times A, which is A squared. Area of the square. So a square is a four-sided figure with all sides equal. Okay, let's assume this is S, this is S, and this is S, this is S. So the area of a square is given by the product of its two sides. So S times S. Given the units are centimeters, that will be the final unit. So let's assume the side of our square was 4 centimeters. So the area will be 4 centimeters times 4 centimeters. So and the product will be 16 centimeters square. Area of the square.
Area of a circle. It's the total surface covered by a circle. Its area can be obtained using the formula by r square. For example,
we want to look at the area of a circle. And the area of a circle is given by r square. So when you're told find the area of a circle of radius 7 centimeters, you have r, so like that area equals to by r square, 7 square. Our area equals to 207, 59. Our area 22 times 7 equals to 154 centimeter square.
Okay, we are now going to look at the area of a trapezium. And first of all, we're going to check what a trapezium is. A trapezium is a four-sided figure where one side is longer than the other, and it is a polygon with 4 angles. To calculate the area of a trapezium, we use this formula: half times h into a plus b, where a and b are the lengths of the parallel sides, and h is the height of the trapezium. Let us now see some of the video. So now you can calculate the area of a trapezium.
To calculate the area of a trapezium. A trapezium is a four-sided figure with one side longer than the other side. That is to say, this is a trapezium because, let's say this is part A, part B. It's a four-sided figure, though B is longer than A. So that's a trapezium. That's the difference between a trapezium and a square or a rectangle. So let's have an example of an area of a trapezium. To find a trapezium, area is equal to half of h into a plus b. So for our trapezium, this part will be the H. A trapezium can also look like this. And this part here will be our H, A and B. So let's calculate the area of a trapezium with A being 12 centimeter, B being 10 centimeter, and H being 4 centimeter. So the only thing we are going to do is to substitute these ones here into the formula. That is to say, area is equals to half of H, and our H is 4 centimeters. Half into 4 times A plus B, that is 12 plus 10. 12 plus 10. Let's go a bit by bit. Half of 4 is 2. That's 2 into 12 plus 10, that's 22. So 2 times 22 will be 44. And since we are calculating an area, the area of our units are in centimeter, that is centimeters square.
Okay, so in length, in real life situation, there are many applications. There are very diverse application of length. First, it helps in the construction to measure and cut materials in required length. Also, it helps in the navigation for measuring distance on maps to determine how far a ship has traveled using nautical miles in ports. Also, in hospitals, it is used to measure a patient height and monitor growth in personal and determining body mass index. Okay, in tailoring, the tailors uses this concept of length to make dresses and measure the making garments. Also in sports, this concept of length is very reliable. It is used in measuring the athlete's racing distance and measuring the swimming pool length.
Okay, another application of length is carpentry. Carpenters rely on measurement to cut wood and assemble them. When we see in this picture, there is a measuring of distance using a thread, like when someone has measured distance in a map. The next picture is also an application for masonry, making level in construction. The next picture is also for carpentry. There is a measuring of wood in order to assemble the required design of either a table, a chair, or anything else.
Hello everyone, we are going to look at angles and plane figures. Under angles and plane figures, we are going to discuss the name and identity type of angles. We will also solve the problems involving angles on a straight line, solve problems involving angles at a point, solve problems involving angles on a transversal cutting parallel lines, state properties of a quadrilateral, solve problems involving angles, properties of a polygon, and apply the knowledge of angles properties to real life situations. Now, the body of content here we have types of angles. We look at the angles on a straight line, angles at a point, angles on a transversal lines, angles, properties of quadrilaterals, properties of polygons, and application to real life situations. So the introduction part, we have a plane is a flat surface such as the top of the table. The intersection of any two straight lines is a point. So we are going to look at the different types of angles.
Acute angles. These are angles that are less than 90 degrees. It's a small angle formed between two lines that meet at a point. Let us look at an example.
Here we have an example of an acute angle. This one is a 90 degrees angle. So we know that acute angle is an angle that is less than 90 degrees. So here you can take this angle here to be something like 45 degrees. So 45 degrees is less than 90 degrees. Hence, it's an acute angle because it is less than.
Reflex angle. Angles that are more than 180 degrees but less than 360 degrees. Example. We're going to have an example. So let's say here is 120 degrees, and let's have here as angle A. So we all know that angle at a point add up to 360 degrees. So you're going to say A is equals to 360 degrees minus 120 degrees. So you're going to have A is equals to 240 degrees. So this one is going to be our reflex angle because it is an angle that is more than 180 and less than 360 degrees.
Obtuse angles. These are angles that are more than 90 degrees but less than 180 degrees. An example.
For example, this is 90 degrees. Let's say here is 30 degrees. 90 degrees plus 30 degrees is equal to 120 degrees. I'm done.
Right angle. This is an angle which measures exactly 90 degrees. An example.
For example, as we had earlier said, right angle is an angle which is adding up to 90 degrees, and also it's coming as due to intersection between two lines. For example, this line and this line, which is perpendicular. Let's say, for example, this lower line has an angle of 45 degrees, and this upper one also has an angle of 45 degrees. So adding these two angles, 45 degrees plus another 45 degrees, give us 90 degrees, which is a right angle.
Angles on a straight line. These are angles that measures exactly 180 degrees. It is as straight on the plane. Two angles of either side of a straight line having a common vertex, which are called adjacent angles. For example, this angle here plus this angle 120 should add up to 180 degrees. Angles on a straight line should add up to 180 degrees. So when I had 120 plus A, it's supposed to give me not more than 180 degrees. Exactly. So you say A plus 120 degrees should give me 180 degree. So I want to get A. I'll say A is equal to 180 degrees minus 120 degrees, which is 60 degrees.
Okay, let us look at angles at a point. Angles at a point are two intersecting straight lines formed for having a common vertex. The angles which are on opposite sides of the vertex are called vertically opposite angles. Let us look at an example.
When we have two intersecting straight lines, it will form angles at a point. Now let's assume that here is 120 degrees. Here is A, here is 120 degrees, and here is 60 degrees. But now we don't know angle A. But we know that angles at a point add up to 360. Meaning we have 120 degrees plus 120 degrees plus 60 degrees plus A, which we don't know, is equal to 360 degrees. Then we have 120 plus 120 plus 60, which will give us 120 plus 120, that's 240 plus. It will give us 300 degrees plus A is equal to 360 degrees. Then we'll have A is equal to 360 degrees minus 300 degrees. Then we'll have A is equal to 60 degrees.
I'm going to present on quadrilaterals. It's a four-sided figure. The interior angles of a quadrilaterals are up to 360 degrees. Examples of a quadrilateral and their properties. Number one is a parallelogram. Opposite sides are equal. Opposite sides are concrete. Opposite angles are concrete. Diagonal bisect each other.
Yes, so let's continue with the properties of quadrilaterals. Property number 2 is a rectangle. In rectangle, we have 4 properties. There are 4 properties. One of the properties, all angles are right angles, and that one is very true because a rectangle is a four-sided figure that 4 angles are equal and they are measuring out to 90 degrees. Every corner of a rectangle is 90 degrees. When you measure a rectangle at the edge, it's 90 degrees. Property number 2 is the diagonals are congruent. That means that the diagonals are equal. When you divide a rectangle into 2 triangles, that is from one edge to the other opposite edge, you'll get 2 triangles, that is 2. That's what we call the diagonal, and the one diagonal is equal to the other diagonal. Then the third property is opposite angles are congruent also. That's why I said that the angles on a triangle add up to, on a rectangle, add up to 90 degrees. That is each angle in a rectangle. So opposite are equal. Take note on that. Then diagonals bisect each other, and that one is very true because for 2 triangles to be formed in a rectangle, that is from one edge to the other edge, yeah, you have to bisect the rectangle, and that is you have to bisect the triangle into 2, and that is now when you bisect from the angles to the opposite angles, it will form 4 triangles. Therefore, it means that the diagonals bisect each other.
Then the next quadrilateral is the rhombus. And the rhombus, it also has four sides. That is, property number one is diagonals bisect each other. As I've said, it's all actually rhombus is just a twisted rectangle. It's almost the shape of the rectangle, but it's just twisted. So it's almost have the same properties as that of the rectangle. So diagonals bisect each other. That one is very true. Then opposite sides are congruent. That one is very true. Opposite sides are congruent. That means they are equal. Opposite sides are equal. Then opposite angles are congruent. That one is very true because opposite angles in a rhombus are equal. Two opposites are equal. Then diagonal divides rhombus into four right angles, triangles. That one is very true. So our next quadrilateral is trapezium or trapezoid. So I've indicated there that legs are congruent. That it means just the opposite sides are congruent. That means they are equal. Then bases are parallel. That means they will never meet. The base of a trapezium will never meet because they are very parallel. Parallel lines means they are lines that will never meet. Then lower and upper bases are congruent. That means the lower line and the upper line that forms the base of a trapezium are equal. Then diagonals are congruent. The diagonals are equal. Then we have the square as the next one, the square. All sides of a square are equal, and that one is very true. All sides are equal. That one is, you can prove it from finding the area or perimeter of a square, because perimeter of a square, you just add the sides and all measurements are equal. So the square are four-sided figure that all sides are equal. Then the next property, all angles are equal. Very true, because all angles measure 90 degrees each, and that means the angles are equal. So we have some more properties, though they are just related to that of the rectangle, because we have bases are equal, opposite sides are equal. We have the diagonals bisect each other. Then we have some others. So our next thing that we're going to talk about is polygon. We're going to talk about the polygon. And a polygon is a three-sided figure. Polygon is a three-sided figure. Triangle is an example of a polygon. So we have a note here to take note. If a polygon has a side, then the sum of the interior angles, that is 2n minus 4, is a right angled. This here is a right angled. Then the sum of exterior angles of any polygon, it adds up to 300 degrees and 60 degrees. The sum of exterior angles of any polygon is 360 degrees. Then a triangle is said to be a regular if all its sides and all its interior angles are equal. Yeah. So let's see what's next. We have properties of polygons. Properties of polygons. Properties of polygon. The sum of three angles of a triangle add up to 180 degrees. For example, we are going to look at a triangle. We're going to look at a triangle. So a triangle in which one of the angles is 90 degrees is called a right angled triangle. Remember, we have some
different types of triangles. So a right angled triangle is a triangle where one angle is 90 degrees. Yeah. Then a scalene triangle is a triangle in which all the sides are not equal. That means the measurement of some sides differs from other sides, they are not same. Then an isosceles triangle is one in which two sides are equal and the equal sides make equal angles. You must know that a triangle add up to 180 degrees. That one is very true. Then in an isosceles triangle, all the sides are equal. I can say that way. All the sides are equal. So that means if all the sides are equal, then all the angles are equal. That means each angle measures 60 degrees. Then an equilateral triangle is one which all sides are equal. And all sides are equal. Then I talked about scalene. Yeah, not scalene, isosceles triangle. Two sides are equal. That means two angles are equal. Two sides are equal. You can find an angle that two sides measure, let's say 50 degrees and other one 50 degrees. Then the other one, we can say it's 80 degrees. So that one is an isosceles triangle because two of the sides are equal, or two angles are equal. So that's properties of polygons. We looked at triangle because it's the perfect example of a polygon.
So now, having looked at all the properties of angles, we are going to look at applications, or rather real life situation where angles can be applied. Now let us start with number one. If you look at number one, we have used by engineers for constructions of roads, building, machine, and houses. So as we scroll downwards, we will be able to see a picture that illustrates on the way we can use angles the way we can apply angles in construction. Number two, we have used by carpenters to create furniture. So that one also we will see in the downward slide. We also have number three as athletes use angles to gauge distance or throw and enhance their perfection in sport. And the last one is clock uses angles to show the time by position of hands. So now let us look at the pictures now. So now we have an application of angle here demonstrated in terms of a picture where we are told to find the angle between clock hands. How do we find this one? We know very well that one rotation is equals to 360 degrees. And for one rotation, we have got 12 hours. So how will we find that one for 1 hour? So for us to find that one for 1 hour, what do we do? Take 360 and then divide by what? 12. Now, if you divide 360 by 12, you will get what? 30 degrees. So that means that for 1 hour, a clock rotates for 30 degrees. And next one also, we can also look at that one of minutes. Now let us look at this one. This one is about construction. This application about construction. As you can see, someone is doing a measurement of distance and a measurement of distance for horizontal one and for vertical one. So that one is also an application of what? Angles and its properties. Let us go to the next. Let us see the next one. The last one, by the way. So the next one is also measurement. You can use it in construction, as I have already said there, that you can use this one in construction. Now you can see someone measuring or with a ruler on a certain table there. So that one is a furniture actually. Let us go to the next one. Okay, the next one is also just about measurement. You can see someone measuring. We have two people there measuring the length of a certain road horizontally. So that is the end of our class, and we want to thank you so much for attending this class. Let us meet in the auditorium for exam. Thank you so much.